Welcome back. With a certainty equivalent concept, a risk neutral decision makers values projects and programs at their expected values. In this case, there is no difference between the expected value and the certainty equivalent. In contrast, a risk averse decision maker values projects and programs at less than their expected value. Finally, risk seekers value uncertain outcomes at more than the expected value. Let's look at these concepts through a diagram. Imagine that we have a risky project where we have estimated the net present value of that project or an investment, and we have the corresponding utility of the net present value. For a risk neutral decision maker, let's assume that utility is increasing in a linear fashion as the net present value is also increasing. For a risk-averse decision maker, as we have mentioned before, they would value the projects and programs at less than their expected value. So we have a curve which is convex. Finally, risk-seeking decision makers would have a utility function curve, something similar to this. Now let's further assume that we have an investment or a project where for a risk-neutral decision maker, they get an expected net present value at the level of n, and the expected utility is at the level of EU. Note the horizontal line which shows where does it intersect with the utility function for a risk-averse decision maker. So where it crosses the utility function line for a risk-averse decision maker, and then if we draw a vertical line, then we get our point A, which is the certainty equivalent value for a risk-averse decision maker. So a risk-averse decision maker has a lower value compared to a risk-neutral decision makers from the same level of investment. Obviously, for a risk-seeking decision maker, this value would be higher, as we have mentioned before. This value would be indicated by point S. So what we can observe here is that depending on people's risk attitude or risk aversion, the utility they derive from the same level of investment would be different. Now, how can we measure this attitude towards risks? There are various ways we can measure this, and for example, either through a lottery game or through asking their willingness to pay with certainty. And once we have a utility function and we have estimated their risk attitude, we can then predict how well they will respond to various incentives or various outcomes of a project. So here is an illustrative example of expected utility function as derived from a lottery and how we can interpret. So let's assume that the utility function is x to the power 1 minus RRA. RRA is the relative risk attitude or risk aversion parameter. So obviously 1 minus RRA, if we assume that RRA equal to 0.6, then the utility of x is the level of outcome, is x to the power 0.4. Now let's assume that there is a lottery which has a 10% chance of having a value of $190 and a 90% chance of having a value of $5. The expected monetary value of the lottery in this case is 0.1 times 190 plus 0.9 times 5, which is equal to $23.5. The expected utility of this lottery is 0.1 times 190 to the power 0.4 plus 0.9 times 5 to the power 0.4, which is equal to 4.69. And the utility of the expected value is 6.64. Now, how do we get certainty equivalent from these specifications. As we have seen in the previous graph, the expected utility for a risk at the level of certainty equivalent gives us the same level of expected utility of the lottery. So what we can see here, we can equate these two expected utility values and then find the certainty equivalent. For example, like this is a mathematical code where we can see that we are solving for a value of x, which is the level of output, where we say that okay, in the first instance, we have 0 0.1, which is the 10% probability times utility from 190, and then this after bracket this 0.4 is our 1 minus the 0.4 is our risk attitude, so it's 1 minus RRA. So this is the RRA. And then in the second component on the left hand side is 0.9, which is the 90% probability times the utility from $5, which we equate to unknown value of utility of x, and but the risk attitude is 0.4, and we're trying to find the value of x. So after solving it, we get an x equal to 13.16. So we have certainty equivalent in this case is 13.16, assuming that the risk parameter is 0.40. You can think of like if we know the certainty equivalent, or if we know the relationships, then we can also calculate people's risk attitude. And often this is being done through using a very simple straightforward questions. Like for example, if we ask, what are you willing to pay for a 50-50 chance of getting $100 and $10? So this is a lottery. Now and if I answer that $45, what does it say about my risk parameter? So what we can say here is that let's assume again that we have a utility function x to the power 1 minus RRA. So we have a 50% chance of getting $100, so we can multiply by the utility, plus 50% chance of getting $10, so we multiply it by the utility. And we subtract the utility from getting $45. So what we are doing here is that we are taking the expected value of lottery, and we are taking the we are taking the expected utility from the lottery, and we are taking the utility from the certain payoff, and we are setting then this must be equal to the difference must be equal, these two outcomes would be equal to 0. And once we set it up, then we can solve it and we can find the relative risk attitudes, which is in this case is 0.43. And the involvement of lottery is a bit more complex, but it gives us a bit more nuances in terms of people's risk attitudes. So there are many versions of experiments or protocols are available to estimate people's risk aversion parameter. I'm going to show you two prominent examples. One is Eckel and Grossman, and the other one is Holt and Lowry. In the Eckel and Grossman protocol, it asks the subjects to make only one choice. So they are presented with a number of gambles or lotteries and asked to choose one that they would like to play. The number of presented gambles can be varied. For example, in the paper presented by Dave et al. 2010, participants were presented with 6 gambles. So here is the gamble scenarios. So for example, let's take one example, gamble 1. We have said that there is a 50-50 chance. So there's a 50% chance of getting a low payoff, and there's a 50% chance of getting a high payoff. In gamble 1, both of them are the same, which is $28. So the expected return is $28, and the standard deviation is 0. So this gamble, or the gamble 1, is a sure thing that no matter what if you choose gamble 1, you will get $28. However, if you go to gamble number 2, there is a 50% chance of getting $24 and 36% and 50% chance of getting $36. So the expected return is $30 and the standard deviation is 6. In the case of gamble number 5, we see that there's a 50% chance of getting $12 and a 50% chance of getting $60. It has an expected return of 36 and the standard deviation is 24. Note that in gamble 5 and gamble 6 both have expected returns of 36. However, gamble 6 has a higher standard deviation, and this has come from the distribution of low and high payoff in gamble number 6. So assuming these gambles, what we can observe from the respondents is their choice, like which gamble they would like to play. And based on that choice, we can classify them into different risk aversion categories. So what we can estimate is that if somebody has selected gamble number 1, then their risk attitude, constant relative risk attitude, is less than 3.46, and they would be classified as risk averse. Whereas if someone has selected gamble number 4, their risk attitude would be estimated between 0.5 to 0.71, and they would still be classified as risk averse. A risk neutral subject should choose gamble number 5, which has the higher expected return but lower variability compared to gamble number 6. However, risk-seeking subject should choose gamble number 6. It has the same expected return as gamble number 5, but it has the high probability of having higher payoff compared to gamble number 5. So if someone has selected gamble number 6, they would be classified as risk-seeking. The Holt and Lowry experiment or protocol is slightly more complex. Here, a participant is typically presented with a list of 10 decisions between paired gambles. The two gambles for each decision are stacked in rows, with gambles in the left and the right columns labeled option A and option B respectively. The participant then chooses which gamble she prefers to play from each pair by picking either option A or B, making this choice for every decision row. So let's have a look at gamble number 1, where we have under option A, there is a 10% chance of getting $2 and 90% chance of getting $1.6. Option B is 10% chance of getting $3.85 and 90% chance of getting $0.1. Which option, if somebody is in gamble 1, which option the respondent would choose? I have selected in this case option A. One thing that could have facilitated our decision is the expected payoff difference, which is 1.17 in this case. However, what else we can see is that option A is much safer compared to option B for gamble 1. As we progress through different gambles, what we can see is that payments are the same, but the probabilities of getting payments are changing. So for example, in gamble 2, there is 20% chance of getting $2 and 80% chance of getting $1.60 under option A. Whereas under option B, there's 20% chance of getting $3.85 and 80% chance of getting $0.1. Finally, if you look at gamble 10, there's a 100% chance of getting $2 and 0% chance of getting $1.6 under option A, whereas under option B, there is 100% chance of getting $3.85 and 0% chance of getting $0.1. The expected payoff differences reflected these changes in the probabilities, says from gamble 1 of where the option A has higher expected return, but then uh, in gamble 8, 9, starting from gamble 5, option B has higher expected return. However, the safer choices are usually option A, except for gamble number 10 because of the lower variability. Now, these are my selections. So I have selected from 1 to 6, option A, the safe choices, and from 7 to 10, I have selected option B. What does it tell this about my risk attitude? So the authors have analyzed the data and they estimated the expected utility from different gamble, and based on an expected utility function, they have estimated the range of relative risk aversion. So if someone has selected only one or none safe choices, they are highly risk seeking. Whereas someone has selected, for example, four safe choices, which is option A, their range of relative risk aversion is between minus 0.15 to 0.15, and they would be classified as risk neutral. If someone has selected 8 safe choices, their relative risk aversion will be between 0.97 to 1.37, and they would be highly risk averse. So if I go back to my choices there, I had 6 safe choices. So which means that I am risk averse based on this table. We'll go through more details in the lab of how to estimate these ranges and the relative risk aversion.